Alright, so we got Huntley High School needs to order new fencing and grass seed for a baseball field. The field is a portion of a circle with a radius of 350 feet and home plate being the center of the circle. First, home and third form a 90-degree angle. How many feet of fencing should be ordered? How many square feet of grass will need to be planted? All right, so it looks like a two-part problem here that we're dealing with. So let's first draw it up. Let's think about what a baseball field looks like. You're going to have essentially what we're dealing with is a right angle, right? And then it's got the, it continues on past that first and third baseline. And then you have something like that, right? Cool. So we said we have a right angle here. We got our, let's say our first, or our home plate down here, right? We got first base somewhere over here, second right up here, and third over here. Okay. And it creates this section. I'm going to change that up a little bit, bring it back down here a little bit. Yeah, there we go. Okay, that's cool. So it creates a square right in there. For those of you that aren't familiar with what a baseball field looks like, this is a terrible rendition of it, but whatever. All right, so we know that we got a 90-degree angle. It's this says that it's 350 feet. Right, that's my radius. And then we got another 350 over on this side, right, because it's still the radius. It's consistent. And actually, baseball fields are not at all consistent. Have you ever seen them? They're crazy inconsistent. It's the only thing that is consistent is the infield. But the outfields are totally different. Some parts of it are totally not. It's crazy how weird it is. I had a history teacher that argued that because it was pre-industrial revolution when baseball was conceived, that there was no real uniform way of doing things. Whereas football, American football, was after the Industrial Revolution, so then people were more systematic about stuff, which is why you see a consistency in football fields rather than baseball fields. Interesting argument. Okay. Anyways, besides the point. We want to figure out how much fencing to get and how much grass seed to order, essentially, or how many square feet we need to account for. All right, so obviously the fence is probably going to be, bumped out a little bit to the side, to allow for a little bit more room back here, right? We won't worry about that right now. If you're thinking to yourself, though, hey, man, I think the fence isn't going to go right along these, you're absolutely correct. For our purposes, let's math it out like this, and then maybe they say, hey, we want to bump it out a bit. Let's get a little bit more fencing. We'll do that. But for now, we'll just find essentially the perimeter of this whole setup. Okay. Well, I've already got 350 and 350, which is 700. So I already know that I've got 7. That is not the marker I wanted. I've already got 700 feet of fencing. I need to figure out this. So let's think about what this is actually a part of. Well, if I continued my fence line, I would essentially create a circle with home plate being my center. This certainly seems like a problem we may have dealt with prior. If I were to find my arc length, I could use that to figure out my fencing. Well, let's see here. My arc length formula. My arc length formula is the arc measure, which is 90 over 360, because that's the total degrees in a circle. And then I would get my arc length of x or whatever. Right, that's what we'll call this guy. This will be x that I'm looking for. Yep, there's my fencing there. I've got all sorts of colors now. This is great. So my arc length, and then that would be over my circumference. My circumference being 2 pi times my radius, which is 350 for this problem. So let's go ahead and figure this bad boy out. All right. Let's see here. So I'd have 2 times pi times 350 times 90 when I cross multiply. I'm doing this on my phone, so it's a little bit tricky, but I'm cross multiplying those two, and I get 197,000 and some change. 197,920.33717, so 0.3 equals 360x. Okay. And I'm leaving this on my calculator. I'm going to divide by 360. And when I do that, divide by 360, I know I need another 549.778, so let's say 0.8 feet, or even 550 feet of fencing to fence that outfield. Okay? Very, very cool. I like it. I like it. Good stuff. Cool. So that takes care of one aspect of this problem. Now we got to figure out how much grass to plant. Let's see if ooh, perfect. It's all stuck together. That's fantastic. So how am I going to figure out how much grass I need? How much area I need to account for? The setup is actually relatively similar. So I have, let's see here. I get my 90 over 360 is equal to x over, well, now instead of my circumference, I'm comparing it to my area. So pi times my radius of 350 squared. All right. So let's cross multiply again. So I'm going to cross multiply these two. I'm going to get, let's see here, 350 squared times pi times 90 gives me 34 million. So 34, comma 636,659.0058, so we'll say 0.0 equals 360x. Alright, I'm going to divide that by 360 now, and I will get 96, not 99, 96,211.3, so 0.27.3 feet squared. That's how much we're going to need to account for seed. So that's gonna be a hefty amount of seed, I'm thinking, that we'll need, or sod even, depending on how fancy we want to get. But we were able to use our lovely, lovely math to figure all that out. Okay? I mean, we could even get even more crazy with this problem. Think about, like, well, what if we wanted to add a dirt track, a warning track right there, if I drew that better, right? If I wanted to make that into a dirt track here and fill that all in, well, now I'd need to, like, subtract out all. Oh, man, it could be wonderful. Maybe we could try one of those types of problems in class, all right? Cool. All right, so this is a problem actually from your homework that I found to be really, really interesting. So I wanted to go through it a little bit with you guys. So here it says many backcountry skiers and snowshoers carry rescue beacons, right? If you're going down, mountains or whatever, you might get lost, or you might have an avalanche or whatever, right? The beacon sends out electromagnetic field signals in circular patterns in the event of an avalanche, right? So there's an avalanche, they send one out so you can get rescued, hopefully. Right? When a searcher encounters the signal, he or she stops, marks the spot, and walks in a straight path until the signal is lost. Then marks that spot. Then they find the midpoint of that path. Meanwhile, another searcher also does this at a different location. Okay, what the heck does all this mean? What's going on here? So this is a real-life, actual application of this that could save somebody's life. So I found this to be really, really interesting, all right? And maybe it's just because I'm super math nerdy, but whatever, man. I think it's cool. All right. So let's see here. Searcher 1, and I'm going to try and draw some lines here using this. So Searcher 1 encounters it, and then they lose it. I'm going to go past so I can, oops, that didn't work. There we go. Okay, so then they create this segment here, basically, that chord of the circle. Okay, and then they said they find the midpoint of it. So we'll say that it's this guy right. We'll say that's the midpoint right there. Okay? Then another, and maybe I'll do it in the same color. Okay. Then another one, we'll do the same thing. So let's draw another line here. Okay, that was actually a decent one. I'll just adjust it a little bit. All right, and then they also have the midpoint. So what they're doing is when the signal starts, they're at the edge of that circle that this thing is sending out a beacon that goes just in a circular pattern. Much like a radio signal would, it's in a circle. Okay, to say so it says this has a reach of a radius of 90 miles, whatever. All right, so then as they hit it the first time and they see that they get the signal, that means they're at the edge of the circle. They keep walking. When they lose it, that's where the other edge of it is. Well, so these are chords, right? Do you guys remember what we talked about with if we have a circle? Okay, if I have a circle and I have a chord of that circle, so I've got my circle, and if I've got myself a chord of that circle, what do I know about the center of the circle? And if I were to draw a line from the center to that chord, to the center of that chord, right? Because we found the midpoints. It would be perpendicular to it, right? That was a terrible right angle. Perpendicular. There we go. So if I were to take, say, a line, right? If I were to take a line that is, hold up, let me get the right stuff going here. Okay, here we go. If I were to take a line and draw one perpendicular through this, right? Boom, right there. And then I were to take another line that, from this guy, that is also perpendicular. Let me do the best I can here. We're kind of run out of space, but you can actually see it right there. Awesome. What does that represent where they intersect? What does that represent where everything intersects? That is, in fact, the center of the circle. So that right there, this point right there, let me try and straighten this thing out a little bit. There we go. Okay. That should be where the skier is. All right, so if they do their whole thing, they find the midpoint, then they do perpendicular to that, where those two intersect is where that skier should be. They use properties of circles, chords, how a segment from the center perpendicular to the midpoint of that chord is going to be the distance. Right? All those different properties we use could have just saved somebody's life, right? Very, very cool in my opinion. This is not so much a math, calculate all sorts of good stuff. This is more of an application over the general ideas of it, okay? Again, I think a very, very cool problem, very much applicable to actual real life. Okay, cool. All right, there we go. Last problem of this video. We got Vanilla Ice is installing some fancy bricks for a door archway. It's a rectangle with a semicircle. So this right here won't be here. It'll be all open, okay? The doorway is 48 inches wide, but we will label it there, okay? 48 inches. He plans to stack the bricks around the arch with the 3-inch side of the bricks. All right, if you guys have ever seen this, what people they'll do is it'll be like this and that. Right, and then they'll continue on, okay, and it will look a lot better than this. But anyways, they'll make their way around that thing with the 3-inch side of the brick. So this is like 3 inches, 6 inches, 9, 12, so on and so forth. And they're going to work their way around this. You see that in a lot of old buildings. So they'll work their way around that nice little decorative piece, okay? So obviously he's fine like figuring this out and this out, but he wants to figure out how many bricks am I going to need to do this whole archway. Well, how can we figure that out? Well, that's a semicircle, right? It's half of a circle. If I found half of the circumference, wouldn't that tell me? Heck yeah. So my circumference is pi times, in this case, why don't I just use the diameter? So that would be, let's see here, 48 times pi. 48 pi is, come on, calculator. $150.79644. So 150.796. That is a lovely 6. There we go. But that's the full circumference, so I need to divide that by 2. Divided by 2 equals 75.398. So we'll say 0.4 inches. But actually, you know what? I don't think I want to round quite yet. Because what's my question asking? My question is asking how many bricks are needed? Well, if they're 3 inches, what would I need to do with that number? Let's divide that by 3, right? Because that's going to be how many bricks. Every 3 inches, I need another brick. So if I divide that by 3, some of you might already realize that you're going to be getting some about 25. So it's going to be 25.13 bricks. So why don't we go ahead and say maybe like 26 or so, Iceman. I was going to do an exclamation point, but I ran out of room because I've got little things that tell me, or that allow me to switch pages and stuff. So we'll just leave it as Iceman. Okay. But yeah, there you go. General idea, right? We're using our circumference, basically like an arc length, but without the degree. Since it was half, we just cut it in half. You could have set it up with our arc length formula and just do 180 over 360 equals x over pi times 48. If you were to cross multiply this out, you'd get the same thing. 180 times pi times 48 divided by 360, you would have gotten this number right here. Okay? So either way, the setup works because it was half. It was just easier to think of it as half, in my opinion. Awesome. Wonderful. America Freedom, rock and roll, Costco flannels. And, yeah.